All right. Hey, ladies and gentlemen, this is Miss Humbert here, and today we're going to be doing Unit 1, Notes 5. So we're going to be talking over linear measure. So let's go ahead and let's take a look at linear measure. So first thing we need to do some definitions. So a segment is a part of a line with endpoints, and so that's actually really important that it has endpoints. Okay, so that's something we need to keep in mind. All right, so how else can we identify it? Well, we can identify it by its endpoints. So that's how we're going to name it. So for example, if we have something, say, M is an endpoint and N is an endpoint, we would name this segment MN. And we put a line above it because it's a segment and we just draw a line instead of not having arrows on it. We just draw that segment. So can you find the length of a line? Well, here's a line. And then it says, can you find the length of a line? And the answer is no. And the reason is that because it extends indefinitely. So it goes on forever and ever, so we can't, oh my gosh, indefinitely is officially the hardest word ever to spell, in case you're wondering. There we go. Okay, so can you find the length of a segment? Yes, you can find the length of a segment because, wow, I am a whole lot of sloppy handwriting right now. Because it ends, okay? So that's how you know you can find that one, all right? So let's take a look at some more things. So it asks us to find the length of AB in each diagram below. So it's not on your diagram, but it is on here. So I noticed that it's going to about here. So I need to do some estimating. Well, first of all, the last whole number was 3, so it's going at least 3 centimeters. And then to me, it looks like it's going 3/4 of the way to 4. So I'm just going to estimate that as 3.75. And then whenever we measure things, we need to make sure we put our units of measure, which is going to be centimeters. So then, let's take a look at our letter B. So for letter B now, okay, 3 is the last number we were at, so I can write 3. And now I need to count how many of these little guys I go over. So then when I count, I have 1, 2, 3, 4, 5, 6, 7. And it looks like we go 7 over. So we go 7, and what we need to do now is we need to figure out how many total there are between the two. Well, there was 5 to the halfway mark, so between 3 and 4, there are 10 numbers. So I'm going to put that on the bottom of our fraction. And then I said it went 7 over. So I have 3 and 7/10, and again, my label is going to be centimeters. Okay, so let's take a look at number 2. So for number 2, I see the last thing it hits is 3. Okay, that's kind of hard to see. So then once it goes to 3, then I notice that it's going to go past it 1, 2, 3, 4, 5, 6, 7. So I'm at 3, and then it looks like it goes to the 8th. So 3 and 8/10. Again, there's 10 between those two numbers. But I notice that 8 and 10 can both be divisible by 2. So when I do that, I'm going to reduce that fraction to get 3 and 4/5. And then I can go ahead and I'm going to label that centimeters. Okay? Now, let's take a look at number 3. So it wants us to find the length of RS. So this is RS up here. So in order to find the length, first thing I want to do is find the biggest whole number near it. So the biggest whole number right before it is 6. So for the length of RS, it's going to be 6. And now I need to figure out how many it goes over. Well, there's 1, 2, 3, 4, 5. So since there's 5 is the halfway, there's going to be 10 between each. And to me, then, it looks like S goes over 1, 2, 3, 4, 5, 6. So S goes over 6. Oh, that's kind of cool. 6 out of the 10. So I can go ahead, again, reduce that fraction because they're both divisible by 2. So then I get 2 over 5, not 3, Miss Humbert, 5. So then I need to figure out what I measured in, and it looks like I measured in, inches would be down here, but here I entered in millimeters. So that's each of these little guys. So the big ones are centimeters. So again, my label is going to be centimeters. Next, let's take a look at number 4. We want to find the length of RS. Well, 1 is the last number it hit, so I know that. And then I have 1, 2, 3, 4, 5, 6, 7, 8, 16 numbers in between 1 and 2. So I notice that S goes over 1, 2, 3, 4, 5 out of the 16. Okay, so we have 1 and 5/16. Now this time our label is inches. So we're going to go ahead and label that inches. Next, let's take a look at number 5. So now we want to find the length of TV. So you'll notice on the bottom that we're calculating it out in inches. So the last whole number it went to is 2. So we're for sure going to have 2. And then there's 1, 2, 3, 4, 5, 6, 7, 8 things in between. So that's going to be the bottom of our fraction. And it looks like V goes over 2 of those 8s. So now we do need to reduce that fraction. So they're both divisible by 2, and I get 2 1/4. So that is my final answer, but I do want to make sure I label it as inches, which also can be abbreviated as just IN if you're the type of person that gets a hand cramp. All right, so now what we're going to do is we're going to define betweenness. So what is betweenness? So betweenness is a point. So we're focusing on this S. So if something is in between, we say that S is between R and T. And it seems pretty obvious, right? Because S is literally sitting between R and T. Okay, so that's betweenness. It's in the middle of them on the line. So now let's go ahead and let's take a look at how we're going to use this. So we want to find the length of XZ if given XY is 4.5 and YZ is 3.5. So let's start by writing down what we know. We know that from X to Y, it's 4.5. From Y to Z, it's 3.2. Now it wants to find the length of XZ, which is the entire length of this line. So to get the entire length of this line, I'm just going to take 4.5 plus 3.2. And when I do that, I end up getting 7.7. And now I'm going to label it as centimeters because that's the label they gave us in the original problem. So that's our final answer for number 6. Taking a look at number 7, it says if X is between S and T. So let's start by writing that. Okay, find X and ST if T, is between S and U. So I'm going to make S and U the endpoints, and I know that T is going to be in the middle of them. So it tells me that ST is 7X, so from there to there. SU, this whole long thing, is 45, and then T to U is 5X minus 3. Now this is where students sometimes get tripped up. Okay, so what I know is ST plus TU is going to equal the entire length of the line. So I'm going to go ahead and I'm going to do 7X plus 5X minus 3 is equal to 45 because this plus this equals all of this. So now I just need to solve that for X. So I have 7X plus 5X is 12X. And then minus 3 is equal to 45. So then I can go ahead and add 3 to both sides. And when I do that, I end up getting that 12x is equal to 48. So then I'm going to go ahead and divide both sides by 12, and I get that x is equal to 4. Okay, so now I know that x is equal to 4. So what I need to do is I need to actually solve that to get what the length of ST is. So in order to get the length of ST, I need to plug that in. So I know that ST is 7x. So then in order to get ST, instead of writing x, I'm going to plug in a 4. And 7 times 4 is 28. So ST is equal to 28 and x is equal to 4. So let's go ahead and we need to find the value of a and xy if y is between z and x. So we're going to make x and z the endpoints. X and z are my endpoints, and y is my middle point. Okay, so xy, it tells me, is 3a. xz, this whole thing, is 5a minus 4, and then yz is 14. Okay, so then again, what we do know is that this plus this equals all of this. So I'm going to write that algebraically. 3a plus 14 is equal to 5a minus 4. Okay, so now what I want to do is get my a's on the same side. So I'm going to go ahead and subtract 3a over to the other side. So then I get that 14 is equal to 2a minus 4. Then I'm going to add 4 to both sides. And I get 18 is equal to 2a. Divide both sides by 2, and I get that a, or just random lines. I'm still learning how to use this new program. A is equal to 9, okay? So A is equal to 9, or apparently G as it looks like on here. So now I need to find the value of xy. Well, it says that xy is equal to 3a. So then to get xy, I'm going to take out the 3 and I'm going to substitute in the a. So then when I multiply that out, I end up getting 27. So that is the length of that guy. Okay? So now, let's go ahead and let's take a look at congruent segments. Now, congruent segments is something that we're going to be using in geometry for a long time. So, I'm going to say here that MN, that segment, we want to draw the line over it to note that it's segment, is congruent to PQ. Okay? Because MN and PQ have the same measure. Okay, so that's really important. If something's congruent, that means it has the same measure. Okay, so this right here is your congruent symbol. So it's an equal sign with a little squiggly on it. And in geometry, that means congruent. That means their length or their measures are the same. So this here is MN, and this here is PQ. So we know that they're equal to each other because they're both 2.1. Okay, so something I want you guys to notice is that segments can be congruent, and that means that their lengths are equal. Okay, so that concludes your note video for today. Please let me know if you have any questions. Thanks for listening.